Welcome everyone. Today we talk about the Schulze voting method. This is a method that can be used when there is no controversial winner. In our example, a group of people is choosing a hike. They have 4 choices: Bridge to Nowhere, Malibu Creek, Sandstone Peak, and Temescal Canyon. We use initials to represent the hikes: B, M, S, and T. Here is the group's preference schedule. This means that, for example, 7 people ranked the hikes as Malibu Creek first, Sandstone's Peak, Bridge to Nowhere, and Temescal Canyon. This method consists of 3 stages. The first one is head-to-head comparisons to decide who is the winner of each pair. So, we look at all the pairs. We start with Bridge to Nowhere against Malibu, against Sandstone Peak, and against Temescal Canyon. Then we have Malibu Creek against Sandstone Peak and against Temescal Canyon. And finally we have Sandstone Peak against Temescal Canyon. We have 6 pairs. We need to decide who wins in each pair. We're going to start with BM. We look at the first column and see who is ranked highest, B or M. In this case, M is ranked highest, and therefore M receives 7 votes. Now look at the second column. Look at M and B. M is higher, and therefore M receives 4 votes. Next column, B and M. B is higher, so B receives 3 votes. And the last column, M, B, M is higher, so M receives 5 votes. We add up these numbers, so Bridge to Nowhere receives 3 votes and Malibu Creek receives 16. The winner of this pair then is Malibu Creek. We do the same with each of the other pairs. So look at the second pair, B and S. See who of these 2 candidates is higher in each column. S is above B, S is above B, S is above B, and S is above B in every single column. So S gets all the votes. S gets 7 plus 4 plus 3 plus 5, which is 19 against 0 votes for B. Now look at the third pair, B against T. B ranked higher than T in the first column, but then T is above B in each of the other 3 columns. So B gets 7 votes from the first column, and T gets 4 plus 3 plus 5, which is 12 votes total against 7 for B. For the next pair, M versus S, M is higher than S in all columns except the third one. So S gets 3 votes and M gets 7 plus 4 plus 5. Adding up, we get 16 votes for M, 3 votes for S. Next pair, M versus T. M is highest in the first column, but then T is above M in the other columns. Therefore, M gets 7 votes from the first column and T gets 4 plus 3 plus 5. This gives 7 against 12 votes. Finally, the last pair, S versus T. S is higher in the first and third columns. T is higher in the second and fourth columns. So S gets 7 plus 3 votes and T gets 4 plus 5. We add up and we have 10 versus 9. So the winners of each pair are M in the first pair, S in the second one, T in the third, M in the next one, T in the next one, and S in the last one. Now we ask, is there a Condorcet winner? Let's look at all the pairs and see if there is one candidate, in this case one hike, that wins in all its pairs. And we can quickly see that that's not the case. B loses in the first 3 pairs, S, M, and T lose in the other pairs. Therefore, there is no Condorcet winner. Whenever there is a Condorcet winner, we automatically declare that Condorcet winner as the Schulze winner, and we're done. In this case, because there is no Condorcet winner, we have to continue. And here's where the first new steps come up. So far, we've done the same work that is usually done to find a Condorcet winner, if any, or in Copeland's method. We look at the winning margins, which is the difference in votes between the winner and the loser. So by how many votes M wins over B in this first case. And that would be 16 minus 3, which is 13. That's the winning margin. We do the same for each pair. So we have 19 minus 0, 19, 12 minus 7, that's 5, 16 minus 3, that's 13, 12 minus 7 is 5, and 10 minus 9 equals 1. Now we're starting our second phase. We're going to use all this information to create a drawing called a digraph. We use the information from stage 1. We use points to represent each of the hikes or candidates. We use arrows that always go from a winner to a loser for each pair. And we're going to write the winning margins right above the arrow. In our example, we have 4 hikes, so 4 dots, which we label B, M, S, and T. Then we draw all line segments connecting pairs of points and use the previous information to complete the digraph. So look at the first pair. M wins over B, which means the arrow from M to B must be there, and the margin of error is 13. Next pair, S versus B. S wins, so the arrow goes from S to B, and the margin of error is 19. Next pair is T versus B, which corresponds to this line segment. T wins, so the arrow goes from T to B, and the margin of error is 5. For the next pair, M wins against S with margin of error 13. So the arrow goes from M to S, margin of error 13. Next pair, T wins over M, margin of error 5. T wins over M, so the arrow goes from T to M, and the margin of error is 5. And finally, the last pair, S wins over T by 1. S wins over T, the arrow goes from winner to loser by 1. So now we have all the information in this drawing. Everything that we did before is included in the drawing. So for example, who would you say is the biggest loser? Arrows point towards losers. So the biggest loser here will be B, because all the arrows are pointing towards B. Similarly, a big winner will be one where all arrows are pointing out of it. So a Condorcet winner looks like this. And as you can see in our particular drawing, there is no Condorcet winner. Every single point has an arrow pointing towards it. We now forget about the stage 1, since we have all the information represented in this drawing, and we're ready to start stage 3. In this stage, we compare candidates by pairs again, but this time we want to know who is the strongest candidate. To explain this, I'm looking at 2 paths in my graph. The first one is the arrow that goes from S to T. I have it right here. The second path is going from T to S, but passing through M. So TMS, TMS. I'm using these paths to compare T to S. On the one hand, using the first path, I know that S wins over T by a margin of 1. On the other hand, this second path tells me that T wins over M and M wins over S, which in a way is telling me that T wins over S. So which comparison is stronger? Which of the paths is stronger? Note that in the first comparison, we have a winning margin of 1, which means that this was almost a tie. Whereas in the second comparison, both of the head-to-head comparisons have margin of error greater than 1. This one has 5 and this one has 13. So I'm going to define the strength of the path as the smallest of the numbers of the winning margins that are involved in the path. So the first path has a strength 1 and the second path has a strength 5. The second path is stronger. We always go from winner to loser, so we say that T is stronger than S. Now we do this work for each of the pairs, as we did in stage 1, but now we are comparing the strength. Here I have all the pairs, TS, TM, TB, SM, SB, MB. We already work with T versus S. We compare these 2 paths, ST and TMS, which had the strengths 1 and 5. In fact, we need to make sure that there are no other paths in this drawing that connect T to S or S to T. Let me just point out that every time that we get into B, we're stuck because all the arrows point towards B. So if we decide to start at S and we need to make our way to T, we cannot go to B because we will get stuck. So the only way is to go straight to T. We need to follow the directions of the arrows so we cannot go from S to M. So the only possibility to go from S to T is straight following this arrow. That's the path ST that we already have. On the other hand, to go from T to S, we can go to B and get stuck, or go to M and then to S. That's the path that we have. And if we decide to go to M first and then to B, we will get stuck. So these are the only 2 paths that connect T to S or S to T. So the strongest path is TMS, and the beginning of that path is the winner in the path, which is T, and so T is the strongest candidate. For the second pair, T versus M, we can go straight from T to M, and there are no other paths starting from T because the only way to exit T besides going straight to M is going to be and getting stuck. Now we look at paths starting at M. We don't go to B because we get stuck. We can go from M to S to T, and that's the only one, because the only other possibility will be to go to S and then to B, getting stuck, or going from M to B, we get stuck. The strength of TM is 5. The strength of MST is 1, which is the smallest between 13 and 1. The strongest path is TM. The start of that path is T, so T is the strongest candidate. For the next pair, T versus B, remember that there is no way out of B, so there are no paths starting at B to T. And then we need the paths from T to B. We have T to B, We also have TMB, and we have one more. We have TMSB. Now look carefully at the graph and convince yourselves that there is no other path that goes from T to B. To compute the strengths, we look at each of the paths. We have TB, T to B, the only number is 5, so the strength is 5. The next one is TMB, 5 and 13, the smallest of those numbers is 5. And the last one is TMSB, 5, 13, and 19. The smallest of those numbers is again 5. All these paths have the same strength, so they are all the strongest paths. And the good thing is that all of them start with the same hike, and therefore T is the strongest between T and B. Note that even without finding all the paths that go from T to B, we know that for sure the strongest of the two candidates is going to be T, because there are no paths starting at B, and therefore the strongest of the paths is going to start at T, and T will be the stronger candidate. The same observation actually applies to the pair SB and the pair MB. Since there are no paths starting from B, then the strongest of the two candidates, S and B, is S, and the strongest between M and B is M. In any case, for practice, we'll look for all the paths that go from S to B. We have SB, already here. We also have S to T to B, STB. And we also have S to T to M to B, STMB. So STMB. We compute the strengths. S to B is 19. STB, the numbers involved are 1 and 5. The smallest is 1. And STMB, that's 1, 5, and 13. The smallest of the numbers is 1. So the strongest path is SB. It starts at S, so S is the strongest candidate. Similarly, for the pair MB, we're looking at paths from M to B. There is none from B to M. So starting at M, I can go straight to B, MB. I could also go from M to S to B, so MSB. And there's one more, MSTB. MSTB. As you can see, all the paths start with M, and that's why we knew beforehand that M is the strongest candidate. Yet, we're going to find the strengths and finish up with this pair as with all the others. So we're looking at MB. The strength is 13. That's the only number involved, 13. Then MSB, that's 13, 19. The smallest is 13 again. And then we have MSTB, that's 13, 1, and 5. The smallest of the numbers is 1. So the strongest paths are MB and MSB. Both of them start at M, so M is the strongest candidate. Our last pair, S versus M. Let's start at S. We cannot go straight to M because the arrow goes in the opposite direction. We cannot go to B because we get stuck. So we have to go S to T and then to M. That's the first one, S, T, M. There is no other path, from S to M. Now let's start at M. We need to go to S. We can go straight, M, S. And convince yourselves that there is no other path from M to S. The only other way to get out of M is going to be we get stuck. So those are the only two paths. To compute the strength, STM, STM, the numbers involved are 1 and 5. The smallest of those is 1, so the strength is 1. Next is M to S. The only winning margin involved is 13. That's the strength. So the strongest path, the one with the largest strength, is MS. It starts at M, meaning that M is the stronger of the two candidates. All right, we've done all the work. We just have to answer who is the Schulze winner. It works as when we're finding a Condorcet winner. We have head-to-head comparisons, but now we're interested in the strength. We want a candidate that is stronger in all its pairs. As you can see here, T is stronger in the first, second, and third pairs, and it does not participate in any of the last 3 pairs. Therefore, T is stronger in all its pairs, and so it is the Schulze winner. This means that the group is going to Temescal Canyon this weekend. That's it for the method. Thank you all. Bye.